All right, so when we write down a measurement in our labs, especially in the labs, or in Alex, probably not. In Alex has like a unit outside the box for you. But anytime you write a number down in the lab, you need to write a unit, okay? So if we have if we're trying to figure out the proper aspirin dosage and we write down 325, we have no idea what that means. Is that gallons? Is that pounds? We have no idea. We need to label it with a unit, okay? Numbers don't really make sense in science unless we have a unit. Is a fast meter dash time 10 seconds or days? If it's just 10, we have no idea. Okay, so make sure you're writing units with your numbers. All right, in this class, we're going to use the SI system. So what unit should we use for length? Good, meter. Yep. So the metric system is meter. Let's turn on my, oh, that's the wrong button. Now it's going to turn off. There we go. So meters, and how do we abbreviate that? What's the symbol for meters? This M. Good. How about mass? What should we use when we're measuring the mass of something? Kilograms, okay. This base unit we're going to use is called grams. And we abbreviate with grams with G. And then we can put prefixes in front, and that changes the value, okay? How about volume? What should we use to measure volume?
Cube.
Cubed. So volume would be cubed. That's true. So like centimeters cubed is a unit. Okay. The other unit that we're going to use the most is liters. I don't know if I heard that one or not. So liters. But we can also use centimeters cubed. That would also be appropriate. And then time, usually we're going to measure things in seconds in here. Okay, or minutes, okay? And we abbreviate with S. Okay, so we're probably pretty familiar with those. So we were talking about that base unit. We can take like meters, and then if we need to represent a really big number, we can say we have gigameters. I don't know if I've ever heard of that. Or we could do centimeters or millimeters or milliliters, depending. We can change the prefix, and that gives us a unit that's the right size for what we're doing. Okay. Before we go on, let me show you in Alex. So I have a student view in Alex, so just give me a second and I'll show you. There we go. So I try to go through Alex as you're going through. Okay, so if I go to chapter 1, I'm starting my class. If I go over to this sidebar, on the tests, you will have a calculator. You'll have the same calculator, okay? You will also have the data, and you will have this periodic table. You don't get the electronic textbook or the message center, or I don't know what this is, tools. You don't get that on the test, but you get these other things. So if you open up this data, and you're trying to remember, I don't remember how many milliliters are in a liter. If you go to this SI prefixes at the top, it has a whole table. So if you can figure out how to read this table, then you're set. You don't have to write all this stuff down on your note card because it's in the Alex data. So that's kind of nice. And you get this on the test. While we're in Alex, let's just stop here for a minute. So if you go to this hamburger navigator thing, this will tell you where the assignments are. So if you go to assignments, our first assignment is due on Friday. So that's this review chapter 1A. Okay. So first it makes you do this knowledge check, and then whatever you know from the knowledge check, it puts you, like, if you know a lot, then it'll put you further ahead. So do your best on the knowledge check so that you can get as far ahead as you can. A lot of your review chapter 1A will be covered in this knowledge check. So if you can do really good on that, you won't have to do so much on this chapter 1A. This is due on Friday, okay? And then the next assignment is this chapter 1. So if I go to assignments, I can see what assignment I should be working on. So I should be working on chapter 1. I finished the initial knowledge check and I finished this review chapter 1A. Okay, it tells me I'm 100% done. The other thing that I need to look at is my grade book. The grade book is where the scores from Alex will move to Canvas. Okay, and once I get 100% on an assignment, it'll show up as 100% on the grade book, and that locks in. That's like locked. Okay, so if I do another knowledge check after chapter 5, and I forgot some stuff in chapter 2, my assignments will look like my percentage went down. But the assignment, this grade book, I did chapter 2 on time, I will still have whatever score I got when it was due. Does that kind of make sense? And that will probably come up, so just if something looks weird, let me know. But the grade book is where your grade is going to get pulled from into Canvas. Okay, questions while we're in Alex? Or we'll just head back to our slides. Okay, very good. All right. I decided I don't want to leave. Okay, well, let me. Okay. All right. Let's practice a few of these. How many centimeters are in a meter? Good. 100. That one's pretty straightforward. Okay. 100 centimeters in a meter. How many milliliters are in a liter? Good. 1,000 milliliters for 1 liter. How many liters in 1 milliliter?
1,000.
So you're saying 1,000?
1,000.
1,000. Oh, I missed that. Sorry. Where is 1,000? Is it here? That's hundreds. This one? I don't know how to use the eraser, or I would have figured. Let's see. There we go. Like that? You agree? Okay. So this is this many liters, 1,000 liters in 1 milliliter. Okay. And we could get to this if we move the decimal 1, 2, 3, and then move the decimal 1, 2, 3, then that will match. Okay, how about this one? How many centimeters in a kilometer? How are we going to figure that out? Okay, can you walk us through your thought process?
So it takes 100 centimeters to get 1 meter. So then if you multiply that by 1,000 meters, then it's 100,000.
Okay, and then you're saying that this is 1,000 meters. Yeah. This is the same. Okay, good. Okay. Oops, and this one should be 100, right? 100 centimeters in a meter. Okay. All right, very good. I don't think Alex has you do metric to English, so we're just gonna skip this part. All right, so look up at these 2 different boxes. We have, in this box, we have 10 fingers, 10 toes, and a definition. We have 1 meter is 100 centimeters. And then in this box, we have 15.3 centimeters, 1,000.8 grams, 0.0034 milliliters. Which of these boxes is exact numbers? Left. Okay, do you guys agree? These ones are exact? So, do you agree that these are inexact numbers? Okay. Okay, so exact numbers are things like we counted it. Unless we mess up our counting, this is exact. Or a definition. 1 meter is 100 centimeters, that's a definition. So that's going to be an exact number. These are measurements. Anytime we're measuring something, we are going to get inexact numbers, okay? So that's just what we talked about. Exact is from counting or part of a definition. Inexact is from a measurement or observation. Our measurements are always going to be a little bit uncertain. They're always going to be a little bit inexact. Yes, they're on the. Yes. Okay. They're on the Weaver State campus. I can email them to you. Do you want me to email them? Okay, I see them. All right, here we go. All right. So I'm gonna hand you out a piece of paper. If I can find it. Oh, it's up here. This is going to be what you're gonna use for your lab on next Tuesday. Okay? So this is the only page that we're gonna copy out of that notebook. Every page says do not copy. So I'm gonna give you this page so they don't have to cut the book. But otherwise we can't cut up the book, or we can't copy the book. We pass one back to each other. Okay, so you're going to use this for lab 1. You're going to measure these beautiful rectangles with your ruler. So when we have a measurement, we get 1 digit beyond what our ruler says. Okay, so this ruler is giving us tens. So when we estimate how big the fish is, we get to estimate to the ones place. We get 1 beyond our measuring stick. Okay. This ruler down here has the millimeters written in. So we get to go 1 beyond the millimeters. So this would be 53 point whatever they estimate in between. So we get 1 estimated digit. Okay. So let's look at your ruler. So look at ruler A. Okay, what's that? So ruler A, how many digits? Or let's see, so how many decimal places are we going to get for ruler A? We get 1 beyond this, what we have. So what can we get? How many decimals? 16. Oh, I see. You're saying, okay. So let's say, what if my measurement is between 5 and 6? What will I estimate?
5.5.
Okay, it'll be like 5.5, right? So I will get 1 decimal place. Okay, I get 1 decimal place with ruler A. What if I am measuring the same thing with ruler B? How many decimal places do I get with ruler B? Good, yes. So if I'm measuring something with ruler B, I get 2 decimal places. Okay, that's what lab 2 is all about, is and sig figs. But if you're measuring something with ruler B, I am going to be looking to see if you have measured it with 2 decimal places. If you're measuring something with ruler A, you should only have 1 decimal place, 1 beyond your ruler stick. Does that make sense? Okay, so watch out for that when we do this. So this lab has no chemicals, so if you really wanted to, you could go home and do this lab by yourself. But we will have a whole day in class to also do this lab. Okay. But that one's kind of nice to start with because you're just measuring paper. Okay, questions on that? Does that make sense? We're good? All right, the next thing that we need to talk about is significant figures. So this first rule, all non-zero digits are always significant. So this measurement here, we have some uncertainty in this decimal place, okay? But we have 3 significant figures. Okay, 3 significant figures here. This one has 6 significant figures. There's 6 non-zero digits. And then when we start adding in zeros, it gets a little bit confusing. So I'm going to give you another handout. There's a few activities on this. I want you to just do this first part with significant digits. So here I have some rules written out and some examples. And then I want you to try to use the rules and figure out how many significant digits the numbers below have. Okay? So, and talk with your group, see if you can figure it out. Oh, and maybe one. Did you get one? Okay, I'll give you about, let's see where you are in like 2 or 3 minutes. So you can check with your neighbor too. See what they got. Then we'll go over it together.
So, for the first one, it's just explain to me? So this one's 4 because there's a 4. It's 4. Can you dumb it down? Where is this? Oh. This one is 2. Yeah.
Okay, take one more minute and then we will talk about this.
Okay. And this one's 3. Okay.
I just thought it was how the table worked out. This is just for, this is like your note page, so use it however you want.
Isn't this the same number as both 4? It's not. Why is it? What about the 0? Oh, wait, then why is this one 4? If this one's 1, this one is 3. Then it counts all of the things. Leading zeros and 1. 107.
Hey, very good. I'm getting some good collaboration. So your peers are going to be a good resource in this class. So good. I'm hearing some good things. Let's go ahead and go through these together. How many sig figs would this number at the top have? 2, I see 2. I agree with that. This has 2 significant digits. Did I close this and open it again? This has 2. So what I like to do is I like to take my pen and I don't do that. I just draw a line through my number until the first number, okay? So there's our first significant digit. So leading zeros aren't significant. We go to the first number. So the 5 is significant. And then because this 0 is at the end, after a decimal place, it's also significant. So there's 2 significant digits here. Okay. How about this one? Good, 3. All non-zero digits are significant. Good. How about this one? It has 4. That 0 is sandwiched in between non-zero digits. So 1, 2, 3, 4. All of these are significant. So we've got 4. Oh. Okay, how about this one? Just 1. Good. This is just 1. So we go through, we find our first non-zero. So that one's significant. Because there's no decimal, that 0 is not significant. So just the 2 here is significant. This also tells us a little bit about how somebody measured their whatever this 20 is. So if my ruler only has 10 increments, if I say 20, that tells you how uncertain your measurement is. So this could be plus or minus 1 in the uncertain digit, okay? This one would be plus or minus 0.1, okay? That's where my uncertainty is, okay? How many significant digits does this 20.0 have? It has 3. This one has 3. So we have our first significant digit, and then anything after a decimal place is going to be significant. Any zeros after the decimal. So this is significant, this is significant. So this one has 3. These are just like, this is kind of the weirdest thing that we learn. It's just like a rule, okay? Let's see. How about this one?
4.
This one has 4. We kind of cut through those zeros. Here's our first non-zero. Then everything else is after the decimal. So this is significant. This trailing 0 at the end is significant because it's after the decimal. Okay, how about this one? This one has 2. Good. How about this last one? Just 1. Good. Okay. So this is kind of weird. It's just rules to remember. But moving forward, this is something that you are going to have to make sure you're paying attention to in ALEKS and also on the labs. Okay, so watch out for that. If you ever have questions, let me know, and we can go over this again. Or if you're just wondering like how many significant digits do I need to record for this lab or this part of this lab, we can talk about that too. So then these are just the rules. You have these written down. So you can go back to them if you need. Then we have some rules for when we're doing some math with the numbers. So if we're multiplying or dividing numbers, we always use the least sig figs, okay? How many does this top number have, Miles? How many sig figs? 4, good, we have 4 non-zero numbers, so 4 significant figures. How many down here? 2, good. So our answer has to have the least number. So how many should our answer have? We can only have 2 sig figs. So we have to take this number that comes out of our calculator and trim it down to 2 sig figs. Okay? So that's where the next part of your worksheet comes. We need to practice rounding. So if the next digit, so the digit to be dropped, we know we want to keep 2 digits here, 2 significant figures. We're going to drop this one. So this 8 is between 5 and 9, so we're going to round up this digit. If this 8 was between 0 and 4, we would just cut it off. Okay. So how many of you have heard of rounding before? You've done this before, hopefully in math. Okay. This is just a practice. So go ahead and practice. The first 4 are an example. It's shifted all the way to the right. So if you want to look at the example, and then the bottom one is the one to practice. So go ahead and practice, and then we'll check. So we're just practicing rounding the views. This one is rounding 2 pages. So 2 sig figs, I guess. That should fix that. 2 sig figs. This should really be sig figs, 2 sig figs.
Oh, okay.
Like, if we round it up.
Oh, all right, now I understand, thank you.
So it would be like 3. I don't understand why they literally just took off all the number you would drop on 6. Right? No, sorry, I don't know what I'm saying.
All right, do you want another minute? Or are you ready?
Oh, wait, is it after the decimals, but it's
Okay, what would this top number be? If we want 2 sig figs from this number that comes off our calculator, how would we do that? What should it be? 110, good, 110. So this has 2 significant digits, the ones. What if we wanted 3 significant digits? So, okay, let's go back to this one. So we have, this is just a number from our calculator. If we have decided we only can have 2 significant digits, we need to decide how to do that. So we can only have 2 significant digits. So we're gonna look at the 7, and we need to know if we should drop that number or round it up. So this one we're gonna round up. And now it has 2 significant digits.
You're not rounding it up to like 8, you're rounding it up to
Yep, depending on how many significant figures we want. Yep. Okay, so now let's go to this one. What if we say we need 3 significant digits? We want to keep 3 digits. We're going to look at this 2. And this 2, yep, good, we're going to drop it. Good. Now we want 4. So we look at the 3. The 3, we're gonna drop that 3. And this is 4 significant digits. Is that you're following? We're doing okay? Okay. And then 5, we have 1, 2, 3, 4. We want to keep 5 digits. We need to know what to do with this last digit we're keeping. So that 6 is bigger than 5. We're going to round up. 107.4. Oops, 23, 24. There we go. My bad. Sorry. 24. And then this last one, 6 significant figures. 107.237. We will look at this last number. Does that help? Okay. Okay. This moving forward, you will need to know sig figs. You will need to know rounding. I don't want to spend. So what I realized last year, this is from the beginning of last year. What I realized is that the more time you guys have to practice in ALEKS, that's better. So what I want to run through here is just how many significant figures should we have? So how about for this calculation? How many sig figs can we keep? 1, good. This has 1 sig fig. This has 3, we go with least sig fig, so this could have 1. How about this next one? Good. This has 2, this has 3, we go with the least number of sig figs that we can keep, 2. How about this last one? We're going to see 1 or 2. This one has how many? This has 2. How many this?
1.
Good. So we can only keep 1 significant figure. Okay. Does that make sense? Okay. All right. There's other rules for adding or subtracting. So for adding or subtracting, we need to look at the decimal places. We just keep the fewest number of decimal places. So this only has 1 decimal. This has 2 decimal places. So our answer, we're going to have to round so it only has 1 decimal place. All right. So I don't remember what this was. Pull out my calculator. So if I do this on my calculator, 10.11 minus 3.6, my answer is 6.51. But I can only have 1 decimal place. So then I look at this one. Because the number I'm going to drop is less than 5, then I just keep the 6.5. I just drop that. I'm just rounding. Okay. Yeah.
Anything below 5 is dropped.
Yep. Yep. Below that number of decimal places. Yep.
Where does it go for?
If the 1 was before the 5. Okay, let's try that. So if this ended up being like 6.15, so then we would be getting rid of the 5. So then we would round up.
So 6.2.
Yep, good. Okay, what happens if our calculator, what if it's like, I'm making something up, I don't know. 12.4 minus 1 I don't know. I'm making something up. What if we do this? And my calculator gives me, what is this, 10? Oops. Okay, 11. Yes, 0.0. These both have a decimal place. So my answer should also have a decimal. One decimal place, the 10th place. Does that make sense? Okay. So you get to keep that 0. Also with your ruler, if you measure something and it is exactly 5 by your eye, then with ruler A, it's going to be 5.0. If it's on ruler B, it's going to be 5.00. Okay, if it's right on that. You still have to report 2 decimal places, even if that's whatever you're measuring on ruler B or whatever you're measuring on ruler A. You have to keep that 1 decimal place for ruler A, 2 decimal places for ruler B, even if there's zeros. Okay. Questions? We're doing okay? Okay, let's do the same thing with this one. How many decimal places should this answer have if we're subtracting? Good, 1. This should have 1. 1 decimal place. How many decimal places should this second one have? 1. How about this last one? Also 1. Good, that was boring. All 1. Okay, the next thing that we need to talk about is scientific notation. Have you guys done scientific notation in your math classes before? Okay, so this should be a review. If it's not, we're learning it today. So we need a coefficient, then times 10 to the exponent. So this coefficient needs to be a number between 1 and 10, and we count significant figures just based on this coefficient. We'll look at 1. Then this exponent needs to be an integer. Okay, it can be positive or negative, but it needs to be an integer, not a decimal or a fraction. So that's our scientific notation review. So if I have this number, 2,500, and I want to convert it to scientific notation, what do I do? Yeah. Okay. Okay, yeah, close. So you're moving the decimal, right? So you're going to 25. So what we want to do is we want to move this decimal here. It's not really there, but we know that this is between the ones and the tenths.
So 2.5 times 10.
2.5 times 10 to the something. What is that something? We moved it 1, 2,
3.
good. 3, good. Okay, before I wrote this line here, how many sig figs did this have? We've got 2. The 2 and the 5, these trailing zeros don't count because the decimal wasn't really there. So this is 2 sig figs. How many sig figs does this have? This also has 2. Okay, so we look at sig figs. Our scientific notation should have the same number of sig figs as standard notation. Yes?
Why do we only move 3 places?
Because we want that number between 1 and 10.
Oh, okay.
So if I had only moved twice, I would have 25 times 10 to the 2, which is a correct number, but it's not correct scientific notation.
Yeah, got
Okay, yep. Or if we moved all the way, it would be 0.2. Yep, good. Good question. Other questions? Thoughts? Okay, let's try to go the other way. What if, oh, no, yeah. Let's try this one.
it. You move it 2 over to the right.
Okay, so we got 3.6. Times 10 to the 2, and we are moving to the right. So this number is bigger. We need to put a negative here. Is that so that if we type this in our calculator, we'll get back to this 0.036. Okay. This has how many sig figs? Good. How many did this have? It also has 2. These zeros before any non-zeros don't count. So this has 2, the 3 and the 6. So both scientific and standard have 2. Good. Okay, let's go the other way now. How do we do this one? Yeah. Good. Move the decimal. How do we know which direction to go? So this one's not.
So you go with this.
Good, so you go bigger. This is going to give us a bigger number. So 2.8, I'm going to go 1, 2. So this would be 280. How many sig figs does this have? This one has 3. Okay, this 0 is after the decimal, after a digit. So we need to make this have 3. How can we make this have 3? Good, we just put a decimal there. And then we have 3 sig figs. Okay, Alex likes it if you put a decimal at the end of your numbers, so it's not ambiguous. So If it's telling you, oh, you don't have the right thing and you have the right number, it might just want you to put a decimal at the end of your number. So watch out for that. Okay, this is our last problem that we'll do. So how many sig figs does this have? Good. This one has? We're multiplying, so how many sig figs can we report? So we go by least number. We can only have 2. This has 2 sig figs, this has 2 sig figs, so our answer has to have 2 sig figs. But how are we supposed to show that? Shreya? Oh, is your hand up?
Yeah.
Okay. Yeah. So if we put a decimal here, how many sig figs is that?
4.
Okay. So we can have 4. So what's another way? Phil, are you thinking? Okay, so walk us through. What are we gonna do?
You put 3 times to the left.
1, 2, 3.
No, it's 1, 1, 0 times 10.
Okay. Okay. Is this 1.0 times 10 to the third? Do you agree that's 1,000? Do you agree with that? Okay. How many sig figs? 2. Good. So that's how if it's being weird, like this is a weird number to do sig figs with, you can put it in scientific notation. That might come up on Alex, it might not, depending on what questions you get. Okay, I think that's our last. Yeah. We will just. Oh, if you want on the bottom, there's some practice. You can practice putting these in scientific notation. Or I'm just gonna stop. Are there any questions before we stop? Yes, Corbin? That was a good point. Thank you. This is the 4th class that I've shown the slides and no one said that. So I'm kind of embarrassed, so thank you. I will fix that. Okay, other questions? Okay, while I fix that, go ahead and I would probably work on Alex. The other thing to think about is your lab notebook. You can keep your lab notebook at home, but if you want, you can use this time to get the pre-lab done. You should know everything you need to know for the pre-lab, which is going to be due on next Tuesday. Pre-lab, let's go over that really quick. So in your lab notebook, your lab So in the lab book, remember you can't write in my book, you could buy your own and write in it. We're doing lab 1 next Tuesday. So there's some instructions for lab 1. And it has an introduction. It has what safety you need to watch out for. Procedure, some background information. Well, that's the wrong one. Okay. So measurements and significant figures, that's what we just talked about. And then this pre-lab review is what's due before each lab. Okay. This one isn't so important because you can do this one at home. So for all the labs that we use chemicals, all the rest of the labs you have to do the pre-lab before the lab. This one you can do it kind of later. And then you'll do your data while you're doing the lab. Okay, and then there's post-lab questions. Okay. So that pre-lab comes after the lab instructions. You should do the pre-lab before next Tuesday. Okay, so we have like 25 minutes left. Go ahead and work on Alex, work on your lab.